In this video, I'm going to go through the 4 different ways partial fractions can come up in A-level math exams. So this first one is the most, I want to say basic, it's still a difficult topic, but most basic type of question that can come up. What you want to do is you want to replace the fraction that's given to you in the form that's actually, well, it's actually highlighted what form it wants you to write it in. So let's write it out in that form, in the form a over x plus 2 plus b all over x plus 3. In order to compare the two sides of the equation, you want to make it so that the denominator on the right hand side matches the denominator on the left hand side. You can add fractions using the smile and cross method. So you can say a multiplied by x plus 3 plus b lots of x plus 2 all over the denominator, which is the multiplication of the two denominators, can match up to the left hand side of the equation. So x plus 5 over everything on the denominator of this fraction. I'm not going to bother writing it out. Because the denominators are the same, both fractions are same when the numerators also match. So we specifically take out the numerators and we say that the numerator on the left hand side is equal to the numerator on the right hand side, which I'm just going to quickly write out. Our goal now is to somehow find the values of a and b, because then we can replace a and b in the equation that we used initially. How do we do that? Well, we substitute values of x into the right hand side that make it so that the terms are eliminated. For example, when you put x equals minus 3 into this first term, it gets eliminated, and then you form an equation for b. So let's do that. Replacing x with minus 3. Minus 3 plus 5 is positive 2. Minus 3 plus 3, like we said, the a term cancels out. Minus 3 plus 2 here is minus 1. Multiplied by b is minus b. If minus b is equal to 2, then b is equal to minus 2. Let's do the same, but this time replace x with minus 2 to cancel out the b term. So when you substitute in x equals minus 2 into this equation, minus 2 plus 5 is positive 3 is equal to, well, minus 2 plus 3 is positive 1a. So that's it. A equals to 3, because when you put x equals minus 2 into this second term, minus 2 plus 2 is 0, so that cancels out. Now that we've got a is 3 and b is minus 2, we can say that this whole expression here can be represented as 3 over x plus 2. And instead of plus b, you can say minus b, which is 2 over x plus 3. And that's your final answer. Part 2 of this question makes it a little bit more difficult because there's a 2 involved, but the overall method is pretty similar. I'm going to quickly go through it just to show you the difference because of the 2 that's now involved. So we have 9x minus 5 over 2 lots of 2x minus 1, x minus 1. And we're going to write in the form a over 2x minus 1 plus b over x minus 1. I'm going to do this question a little bit differently. You might be thinking, well, how do we take into account of the 2 in the denominator? Well, in this first term, to make it so that the 2x minus 1 matches this denominator here, we need to multiply 2 and x minus 1 to the denominator. Whatever you multiply to the bottom of the fraction, you also multiply that to the top of the fraction. So we're also going to multiply 2 and x minus 1 to the top of the fraction. So it becomes 2a lots of x minus 1 all over this denominator here. 2 and then 2x minus 1, x minus 1. Let's do the same thing to this second term. So to make this denominator x minus 1 match this denominator, we not only multiply 2x minus 1 to it, but we multiply 2. Once again, whatever you do to the bottom of a fraction, you do to the top of the fraction too. So you're multiplying 2 and then 2x minus 1 all over this same denominator. And that's all equal to the left hand side of this equation. That's 9x minus 5 over everything that was already there. 2 lots of 2x minus 1 all multiplied by x minus 1. I'm just going to write it out here because otherwise it gets a little bit messy. Now that we've done that, we can combine these two fractions together because the denominators are the same. And then because the denominators are the same, and we can cross one of them out, and we can match the numerators together just like we did last time. So we can say the numerator on the left hand side, 9x minus 5, is all equal to the numerator on the right hand side, 2a lots of x minus 1 plus 2b lots of 2x minus 1. And just as we did before, we're going to substitute values of x in strategically to cancel out the terms. For example, when you put x equals 1 into the equation, it cancels out the a term. So 9 times 1 is 9, take away 5 is 4, that's equal to, well, this term cancels out. 2 times 1 is 2, minus 1 is 1, so that's 2b times 1, which is 2b. In that case, b is equal to 2. Let's now put in a value of x to eliminate the b term. In this case, you can put in x equals a half, because 2 times a half is 1, take away 1 is 0. Let's do that. 9 times a half is, 9 over 2. Take away 5 is minus 1 over 2. That's equal to, a half take away 1 is minus a half. Minus a half times 2 is minus 1, so that's minus a, in which case a is just equal to a half. Now that we've got values of a and b, we can say this is equal to, a, we're going to replace it with a half, which is 1 in the numerator and 2 in the denominator. And then b, we're going to replace it with 2. And that's your final answer. Great. Option 3 is where there's a repeated factor, so you might notice there's a square involved. Let's go through what to do in this case because it's a little bit different to what we've done so far. Okay, so first of all, we're going to write it out in the form a over this first fraction. So, a over x plus 3 plus b over x minus 1. Now in the third fraction, we're going to write as c over x minus 1 squared. So the factor that's repeated, we write that out as a separate fraction, all squared. Now, once again, we're going to manipulate this so that the denominator matches the denominator that we have in our final answer. So in this first term, you want to multiply the denominator by x minus 1 squared. So you do that to the top of the fraction too. So we have a lots of x minus 1 squared. I'm going to write a massive denominator here because the denominators are going to end up being the same. And no point writing it out again and again. Okay, so this second term, how can we make x minus 1? Or what do we multiply to it to make it match this denominator here? Well, you multiply x plus 3 and also x minus 1. So once again, whatever you do to the bottom of the fraction, you also do that to the top. So we're multiplying b by x plus 3 and x minus 1. Using that same idea, what do we do to this denominator here? Well, to go from x minus 1 squared to everything here, you have to multiply by x plus 3. Whatever you do to the denominator, again, you do to the numerator, so you multiply x plus 3 to c. And now we can make that match the expression that we're given in the question. Again, the denominators match, so we make the numerators match each other. Let's do that. We say 5x squared minus 12x minus 1, the numerator in our expression, is equal to this numerator that we formed. A, lots of x minus 1 all squared, plus b, x plus 3, x minus 1. It's quite a long process. Plus c, lots of x plus 3. Once again, we strategically substitute in values of x to eliminate the terms. So straight off the bat, I can see if we put x equals 1 in, it'll eliminate this term and this term. So let's do that. When you put x equals 1 into this left-hand side, 5 take away 12 is minus 7. Minus 7 take away 1 is minus 8. Like we mentioned, the a term cancels out. 1 minus 1 is 0, so the b term cancels out. 1 plus 3 is 4, so that's 4c. And from there, we can get that c is equal to minus 2. That's good. What else can we substitute in as x to eliminate a term? Well, we can put in x equals minus 3. When you do that, well, minus 3 all squared is 9. 9 times 5 is 45. I'm going to have to write this one out. Minus 12 times minus 3 is plus 36. And then take away 1. So that's the same as 45 plus 35, because 36 take away 1 is 35. And that's equal to 80. So I'm just going to write this out as 80 to simplify things. And that's equal to, minus 3 minus 1 is minus 4. And minus 4 all squared is, minus 4 times minus 4 is 16. So that's 16a. And the b term cancels out because minus 3 plus 3 is 0. And when you multiply by 0, that cancels out. Minus 3 plus 3 again is 0. If 16a is equal to 80, we can divide both sides by 16 and get that a is equal to 5. Now, we can't really substitute in any other variable to get to eliminate a and c so that we can get b. Instead, you can substitute in any other random number like x equals 0, because it's going to form an expression for a, b, and c. But because we have a and c, we can solve it for b. Does that make sense? You'll see what I mean. So when you put x equals 0 into the left-hand side, 0 take away 0 minus 1 is equal to, 0 take away 1 is minus 1, all squared is positive 1, so that's positive 1a. 0 plus 3 is 3, 0 take away 1 is minus 1, so that's minus 3b. And then putting 0 into this last term, 0 plus 3 is, 3, so that's plus 3c. Now we can replace a with 5, so 5 minus 3b, which we want to find, plus 3 lots of minus 2, which is minus 6, is all equal to the left-hand side, minus 1. Sorry, I mixed up the sides here. 5 take away 6 is minus 1, minus 3b equals minus 1. in which case add 1 to both sides, minus 3b equals 0, and we get that b is just equal to 0 in this case. What that means is if we substitute values of a, b, and c into this equation, we actually get 5 over x plus 3 plus 0 over x minus 1 because we found b is 0, but we don't really need to include that, and then plus c, which is minus 2, all over this denominator here, x minus 1 squared. And this, when you expand it out, is what gets you to this partial fractions here. That one took a bit of time, and let's now move on to the last type of question, which you might notice already is a little bit different because there's a constant involved. I'm just going to erase some of this so we have space. Great. I think actually we'll dedicate the rest of the page to this. So it's quite a big question. So what's different about this compared to all the other ones? Well, if you expanded out the denominator, you'd see the largest power of x here is x cubed, largest power of x here is 4x squared, and in all these cases, the largest power on the numerator is always less than the largest power on the denominator in all three of these cases. However, when the largest power on the numerator matches the largest power on the denominator, or is larger than the largest power on the denominator, that's when you have to do an extra step. You have to do long division. So let's do that. We need to start by expanding out the denominator. So 3x times 3x, x is 3x squared. 3x times 1 is 3x. Minus 1 times x is minus 1x. 3x take away x is plus 2x. And then minus 1 times 1 is minus 1. And you divide the numerator by this. So let's do that. To go from 3x squared to 6x squared, you multiply by 2. 2 times 3x squared is 6x squared, 2 times 2x is plus 4x, and 2 times minus 1 is minus 2. And let's subtract now. So minus x take away 4x is minus 5x, and 1 take away minus 2 is 1 plus 2, which is plus 3. So we can say that this divided by this, just like it's represented here, is 2 plus a remainder of minus 5x plus 3 all over what we're dividing by. 3x squared plus 2x minus 1, which I'm going to write as this double bracket here. 3x minus 1, x plus 1. And just like that, we've actually found the value of a already, is 2. Now that the highest power on the numerator is less than the highest power on the denominator, which is 3x squared, what we can do is split it up just like we did in all these other cases. So let's only focus on splitting this up. I'm going to speed through this a little bit because, well, we've gone through how to do this already. But yeah, we write it in the form b over 3x minus 1. I'm just using b here, I'm not using a because we've already established what a is 2. Plus c over x plus 1. So to make this term match this denominator, we need to multiply top and bottom by x plus 1. So b lots of x plus 1. To make this match the denominator, we multiply top and bottom by 3x minus 1. So c lots of 3x minus 1. All over this common denominator of 3x minus 1, x plus 1. Matches the left hand side of the equation, which is minus 5x plus 3, over this same denominator, 3x minus 1, x plus 1. Once again, we match the numerators to each other, so we say that the numerator on the left hand side, minus 5x plus 3, is equal to the numerator on the right hand side, b lots of x plus 1, plus c lots of 3x minus 1. Once we've reached this stage, we can again strategically substitute in values of x to eliminate the terms. So in this case, we can eliminate the b term by replacing x with minus 1. So when x equals minus 1, minus 5 times minus 1 is positive 5. Positive 5 plus 3 is 8. That's equal to, well, the b term cancels out, and 3 times minus 1 is minus 3. Minus 1 is minus 4, so that's minus 4c. Divide both sides by minus 4, and you get that c is equal to minus 2. Lastly, we can make the c term equal 0 by substituting in x equals a third. So let's do that. Minus 5 times a third is minus 5 thirds plus 3. To add this easier, I'm going to replace 3 with 9 over 3 so that the denominators match. And we can easily see that 9 take away 5 is 4. So we can write this all out as 4 over 3. And that's equal to, well, a third plus 1 is again 4 thirds, b. And putting a third into this expression here cancels out the c. And if 4 thirds b is equal to 4 thirds, then b is equal to 1. Now that we've got what b is, we can replace b with 1. And now that we've got what c is, we can replace c with minus 2. So you'll find that answer is 2 plus 1 over 3x minus 1 So let's write here 2 plus 1 over 3x minus 1, and then replace c with minus 2. Minus 2 over x plus 1. And these are the four main types of questions that can come up in partial fractions. Hopefully this video summarized everything about partial fractions, and it's quite an easy topic to forget. But yeah, we went through the most normal format. We went through what to do when there's a constant on the denominator. We went through repeated factors and also improper fractions. Yeah, be sure to like the video if it helped and subscribe. I'll post more content like this very soon.